Okay, everyone, welcome to the Lab 2 demo. Today we're going to be talking about descriptive statistics and how to use SPSS to get us those very special numbers that we need to complete our labs. So you will find the Lab 2 demo posted on the course iSite, and you are welcome to follow along there. And we will also be using the data for this lab called cosmetic surgery. You will not find that on the iSite. Please remember, IBM and Google are two different companies at this point. So the iSite will not uh, take a file that is an SAV file. So in order to find the cosmetic surgery, you'll have to actually get into your Google folders and go to the folder that I shared with you earlier in the semester and open up the data files, which should be in your lab demo folder, and you'll have to open up cosmetic surgery. And so once you do that, you'll see something that looks a little bit like this. So again, we're going to be using the cosmetic surgery file today in order to do our lab demo. So just like we have learned in our class lecture today, we are going to be doing descriptive statistics, which means we are not going to be going through that very scary cloud of probability. We are just going to look at the sample that we have collected, and we are going to describe that data. We are not going to do any p-values. We're not going to do any fancy statistics today, even though we learned about that in the lecture. Today, all we're going to be doing is the exploratory data analysis, also known as descriptive statistics. Okay, so again, the goal of the descriptive statistics lab is to be able to describe the sample. Okay, and so we're going to be doing this in a couple of different ways. We're going to be doing this numerically, and the numeric part of this is actually going to be a little bit of a review for us. But the new part that we're going to be adding is how to visually describe the data as well. And you'll see as we get into the charts and the graphs a little bit later in the lab that there are a lot of different options that you'll be able to do to make your charts and graphs look fantastic. I'm going to kind of give you the bare bones today, but do find a little time to play around with it because these visual tools can be very powerful. I know I'm a very visual person, so being able to see the data in a chart or a graph actually makes more sense to me sometimes than just looking at numbers. So the tools that we're going to be adding to your toolbox today are we're going to learn how to do some bar charts, some histograms, some box plots, some scatter plots, and then we're even going to be working on our bivariate skeleton tables. And again, you're not going to be able to look up what skeleton tables mean on the World Wide Web. This is sort of something that we kind of made up here in the GPH department. But again, the skeleton tables are what you are going to be creating in your lab to show me that you understand the specific statistics that you need to report in order to describe your data. But you will also be adding some visual tools to your Lab 2 assignment. So stay tuned here. Okay, so again, this is part of the lab that is a little bit, let's say, review. Okay, because we have used the explore command before when we were looking at the last demo, which was T makes you brainy. Okay, so what I want to do now is I want to go over to the actual data set here. So again, this is cosmetic surgery. And whenever you have a brand new data set that you're unfamiliar with, going through and actually doing some descriptive statistics, some exploring of the data is really the best way to understand the data that you have in front of you. And that's why we started Lab 1 by describing all of the statistics that we have in our BRFIS data set. So you went through and you gave me a mean and a standard deviation for all of the continuous variables, and you gave me a number and a percentage and did some frequency tables for all of the categorical variables. So you could do the same thing here, but I'll tell you that the part of this data set that we're going to be using today, because we will use this data set several times over the course of the semester. The interesting part of this is this Beck depression inventory. And so this, the Beck's scale for depression is actually a real scale for depression. You can look that up, and it's a validated tool to try to understand an individual's depression. And so what I want to do here is look at it. We can tell here that it is a scale. There is no value labeled here. So it is a continuous variable. So what I want to do is I want to go up to Analyze, go to Descriptive Statistics. That's the name of this lab here today. And I want to go to the Explore tab. Okay, and so the BDI, or the Beck's Depression Inventory, is really what we want to be looking at. Okay, so I'm going to go ahead and press OK. And then again, automatically what happens is when you are in SPSS, when you ask the data to do a command or to run a command, the output window will automatically pop up. So you can see that here. And we have the descriptives for our continuous variable. So we can see here that the mean is 23.05. We can see the standard deviation is 15. We can see the minimum and the maximum, and it really gives us a good idea of what this variable looks like in our participants. Now, you can see here that we have far more participants in this data set than we did with the Team Makes You Brainy. We have 276 people that are here in this data set. Another way to look at that is if you go back here into the other window of SPSS, you can click on Data View, and you can scroll all the way down until you get to 276, and you can see that this is the last row of data. So this is the last individual that's been entered into our data set. So if we go back here to the output, these are the descriptives that come up when we ask for the Explore command. So if we go back here to our lab demo, you can see that I have the step-by-step. So you go to Analyze, Descriptive Statistics, and Explore, and I will try to be as consistent with how I'm labeling the commands as I possibly can be over the course of the semester. But I also have a screenshot here of what the descriptives are that we kind of want to pay attention to. And again, this should be a review for us, not only of Lab 1, but also this should really be a review of the Psych Stats class that you guys had to take in order to qualify to come into this class. It was a prerequisite. So we should be pretty comfortable with the terminology that we're seeing here. And if not, you're always welcome to Google any of these terms here to figure out exactly what they mean. Okay, so step 2 of our Lab 2 demo. In order to visualize the distribution of this variable, we can describe it with the numbers that we had above, right? We had the mean, the standard deviation, we had the minimum, the maximum. All of those numbers are really telling us a lot about the data. But for me, I don't really understand what the data looks like until I see it with a graph. So what I want to do right now is I want to go here to back to the SPSS data set, and I just like to be in variable view so I can sort of see what I'm looking at. But what we want to do now is we want to go to graphs, and we want to go to chart builder. Sometimes an error message will pop up. I'm not quite sure why that is. But what I'm going to do here is make sure that we're all reset, because this is how it's going to pop up when you guys are looking at it. Okay, and so what you want to do here is choose from your graphs over here, the type of graph that you want to do. So right now we're going to do a histogram, and it's kind of nice because you can drag and drop, and then all of a sudden this more information on exactly how you want your histogram to pop up is going to come here. And then you also have your list of variables. Thankfully, this is just a short list of variables because this is just the dummy data that we're using for the demonstration. But really what we want to do is we want to understand the distribution of Beck's Depression Inventory, or BDI. So you can go ahead and drag that into the x-axis here, and then we can just go ahead and say okay. And so this is what is going to pop up for us. And so what we can see here is we have sort of a peak around maybe 10, and then we kind of come down here and we have sort of a valley between about 20 and 25 or 30, and then we pop back up again and we go back down. So this to me looks like it's a bimodal distribution. Okay, this does not look like a normal distribution because we have this dip here in the middle. Okay, a couple other of the statistics that pop up here are our mean and our standard deviation, and then also how many people are included in the histogram. So this is really great information. If you double click on this, it'll bring up sort of your chart editor. Okay, and so this is what I'm talking about when I say you can kind of play around with the chart. You can play around with what you want the axes to say. So right now this says frequency, which is what we want it to say, and then we have the entire label for the variable down here, Beck depression inventory, which is great. You can change this, and instead of saying simple histogram, you can double click and just say, I kind of want it to just say histogram. Or you might want to say descriptive histogram of the Beck's depression inventory, or maybe that's too long, so you're just going to say BDI. But basically, if you double click on your output screen, you'll be able to come up with all of these different options. And you can kind of scroll through here and say, oh, we want to maybe not have the legend, so you can hide that if you'd like to. You can include a text box or a footnote. You can also decide that you'd like to change the color. So you can change the background color, you can change the color of the bars if you'd like to. Again, all I did was double click here on the bars, and you can fill it in with whatever you'd like. I don't know why I don't like that black one, so let's go ahead and apply that. And then there we go. So we can close that, and then all of a sudden now it's green. Just a note, even though I've chosen kind of a strange Easter egg color here, I do want you to make sure that when you're doing this with the Burfus data set for your lab, that you choose something that is, publication ready. And usually these publication journals would charge a lot more money if you wanted to print in color. So maybe choosing a gray, a dark gray would be better and cheaper for you if you decide to publish a chart like this. So you can close that, and you can go ahead and see that it's changed our graph here. In order to get this into your lab, for example, or into your demo, please feel free to do a screenshot. I have noticed over the years that some SPSS versions, you can right-click, copy, and then paste it into a Word document or a Google Doc, although sometimes with Macs, that's a little bit wonky. So I highly recommend for your Lab 2 to do a screenshot and then to pull that over to your Word document or your Google Doc. It seems to be the best way. However, depending on what computer you're working on, sometimes a right click will allow you to copy the chart and then paste it in whatever document that you are working in. Okay, so that is part 2, and we'll be moving on to step 3 here in just a minute. Okay, so what we're going to do now is move on to step 3. We want to visualize the distribution of that same variable, that BDI variable, but this time what we want to do is we want to look at a box plot. Box plots tend to be a little bit better in order to look for outliers. Sometimes you can see them in the histogram, and sometimes you can't, unfortunately, just because sometimes there's there's a lot of data, and if you have 1 or 2 outliers, they're really not going to show up, given the fact that the frequencies might go up to 1,000 or 10,000. 1 or 2 people won't show up, but in a box plot, you'll always be able to identify any outliers. So what we want to do now is we want to go back to SPSS, and then, and then we want to go to graphs, and then go to chart builder, which brings up the same thing that was just there. If you still have your histogram up here, you can always just press reset and it'll just clear out anything that might be there. But what we want to do now is we want to go to box plot, and the first one here is the one that we want to be using. So again, it just kind of comes up with a simple box plot for us. We want to take the Beck's depression inventory and actually put it over here in the y-axis, okay? And then we want to go ahead and say, okay. So here we have the simple box plot, and the same rules apply. You can go ahead and double click on this. You can add something else here. You could add a legend. You can change the color of this. And again, depending on what type of a computer you are on, if I right click right here, which is what I just did, I can copy this. And then I can take this exact chart, I can go back to something like a Google Doc, for example, and I can, again, right click and do paste. And then the whole visual comes right here for me. I can make it smaller if I need to. It's kind of what I did up here actually as I was going through the demo for you. Sometimes that works and sometimes it doesn't. So for your lab, just remember when I ask you to visualize the data, what I'm asking you to do is actually do these charts, and you need to copy and paste these charts from your SPSS output into your Word doc. And you can do that either by right-click, copy, right-click, paste, or you can screenshot and put it directly into your document that you're working on. Okay, so we're going to move on to part 2, which we are going to look at Beck's depression inventory again, but instead of looking at it as a continuous variable, we want to create an ordinal variable or a categorical variable. And so we've done this a couple of times before. You've done this in your lab 1, and we did this in our demo before, but we're going to do it again. And so what I want to do is I want to take the continuous variable of Beck's depression inventory, and I want to create 4 different categories. So this 0 to 13 is going to be known as minimal depression, 14 to 19 is mild, 20 to 28 is moderate depression, and then 29 to 63 is going to be severe depression. So in order to do that, what we want to do is we want to go back here to our SPSS, we want to go to transform, and we want to recode into a different variable. So again, we've done this before, so this should be review, but we're going to take the Beck's depression inventory here, and it says BDI, and it's asking us, what do you want to create? So I want to create BDI underscore cat or category. And so this is just, I'm going to label it as BDI with 4 categories. Okay, and when I press this button change here, the question mark goes away, and now SPSS knows where we are coming from and where we are going. But now we have to tell it what the old and new values are going to be. So I'm not going to remember them all, but I think the first one was a range of 0 to 13, and that one was going to be, and that one was going to be the range here, yeah, the range is 0 to 13, and then the new value is going to be a 0, and we're going to go ahead and add that. And then the next one, oh, I think I remember it, 14 through 19 is going to be the slight, I forget what the name is. We'll do the labels in just a second. That one's going to be is going to go to a 1. And then I think we had 20 to 28, and that we're going to give it a value of 2. And then I can't remember exactly what it was, but I think it was 29 to the highest. I think it was 63, but just to be on the safe side, I can say through the highest number, and we're going to make that a level 3. And we're going to go ahead and say okay, and continue, and say okay, and then we're going to be taken to our output. Now, as you can see here, when we do the output, all that we have here is the code. This is the command. We went through and did sort of the point and click part of SPSS, because that's honestly much easier than memorizing all of this, this code down here, but that's all that's going to pop out. Okay, so if we go back now to our variable view, we'll see here that we have BDI cat, which is the one that we just created. I hate all of the decimal points, so I always change that to 0. But now what we have to do is we have to go in and we have to remember what all of the these were. So I think 0 was minimal, and then 1 was, God, what was it? It was slight or something? Mild? I can't remember these things. Okay, so 1 is mild, and then 2 is moderate, and then I think 3 is going to be severe. Okay, so we went ahead and we had to add these in here, and all of that will appear in the value section. And then what we want to do here is we want to say that this is an ordinal variable. Now, if you don't exactly remember what the ordinal variable is versus the nominal variable, a nominal variable is a category that really doesn't have any order to it. So it's just different categories. So a really good example of this would be gender. There are many different gender categories, but they don't necessarily have an order to them. Whereas the BDI categories actually do have an order. There is an order that goes from smallest, or the least affected by depression, all the way through the highest score, or the most affected by depression. And so we can change in the variable view, we can change it from nominal to ordinal, because it does actually have a natural order to it. Okay, so now that we have our ordinal variable, minimal, mild, moderate, and severe categories of the BDI, what we want to do here is we want to describe it with numbers first. So again, this is review. We're just doing a frequency table here, and so we should remember how to do that. So if we go here to analyze, we want to go to descriptives, and we want to do frequencies, and we want to go find the variable that we just made for ourselves, and we want to go ahead and say okay. And here what we have is the frequency and the percentage, and because we have no missing, the valid and the percent, the valid percent and the percent are identical. So what you can do here is you can go ahead and you can enter in these numbers into your lab. So I think this was 103 and it was 37%. And then you can go kind of back and forth between the SPSS output 32, 32. So if we go back here, this is 32, and I think it was 12%. And this was also 32 and 12%. And then if we go here to the output again, we have 109, which was 39.5%. So this was, what was it, 106? And it was 39.5%. Okay, a couple of things that I've done here that are very common errors. If I have the percentage up here, when I put the percentage here, it's actually a little bit distracting. You can keep it. You will never lose points for having that. But technically, if you tell me that the number that is in the parentheses is a percentage, you do not have to use the percentage sign. Okay. The other thing that I did here is I am not being consistent with my significant figures. So here I have a percentage with no decimal place, no decimal place, no decimal place, but here I do have a decimal place. So I think it's really important to make sure that you are consistent with your significant figures. It's something that I see all the time, and I do correct that on your labs, but it's something that you should get into a habit, a good habit when you do this. Okay, so as we're following along here, of course, that's not the only way we want to describe our new categorical variable. What we want to do here is we want to go and do a simple bar chart, and we want to look at the different categories of depression. So if we go back here to our cosmetic surgery, and go to here, go to graphs, go to chart builder, and again, I can just press reset and everything will go back to the way that it was. We can go to a bar chart here, drag it up and drop it. See if I do this again. There we go. We drag it up and we drop it. And again, now what we want to do is we want to pull our BDI categories here. And because we went through the the extra step of telling them that this was an ordinal variable, we have this information here, and it's going to automatically go in the order in which it goes from 0 all the way to 3. Now, SPSS will likely do this anyways, but it is good to make sure that we have the minimal, mild, moderate, and severe is going to be in the correct order. So we go ahead and press OK. Okay, and then here we go to our output, and we can see here the number of minimal, mild, moderate, and severe cases. Okay, BDI with 4 categories is down here. The count is here. And again, we can double click on this graph. We can change the colors, which you'll have to do for your lab. But you'll also see here, well, maybe BDI with 4 categories is the way that, I label the variable, but might be a better way to label that x-axis. Okay, and again, you can right click and you could copy and paste it here if you'd like to, and you can, make it smaller or bigger depending on where it's going to fit in your graph. And again, just a little note here. Go ahead and double click on the graph and actually make some of the changes in the chart. Find the way that works best for you. Sometimes I just like to stick with whatever is simplest, but you can kind of play around with it and just see how many different ways you can change the chart itself. Okay, so now that we've done that, let's go ahead and examine the relationship between actually 2 variables. So instead of just working with BDI for the rest of the lab, let's add in another variable here. And I wanted to just take a quick moment and say that when we're doing these sort of the statistical analyses, it's always good to start with a research question of interest. And it's something that we're going to start introducing to your lab starting this time around. So the idea of having like a background information or a research question of interest to sort of start off your analysis, giving your analysis a reason is a really good place to start. So I have 2 sample research questions here. Is there a relationship between gender and depression? And is depression severity related to gender? Okay, so these are the 2 questions that we're going to work on solving. Okay, and the first step is always to make a skeleton table. Okay, so here's our table, and I'm just going to name it the relationship between gender and depression, because that's really what we're asking for here. Okay, and we're going to look at 2 different measurements. We want to look at the mean and the standard deviation, and we want to look at the median and the interquartile range for that BDI. But instead of just looking at it overall, which is what we've done sort of above here, we want to add in the second variable. So the second variable for us is going to be gender, and we're going to have 2 gender categories here. We have male category and female category. Okay, so if we follow along with the steps here, what we want to do is we want to describe the relationship numerically first. Okay, and again, this is review. So what we want to do here, we want to go here, we want to say analyze, descriptives, and we want to explore. Okay, so I'm going to go ahead and reset this, because what I want to do is I want to pull gender into the factor list, and then I want BDI, the continuous BDI, because we want a mean and a standard deviation and a mean and an interquartile range, which means we need to use the continuous form of the variable. I just want to look at the statistics right now. I want to numerically describe everything, so I go ahead and say okay. And here we can see with the descriptives, we have the descriptives are broken up. Okay, so we have the mean, the standard deviation, we have the median and the interquartile range just for females, and then we also have it just for males. Okay, so you can go ahead and take the statistics that we have here on this column, and we can add them here to our table. Okay, so give it a second and go back and forth, toggle back and forth, and look to see if there are any differences that you can see sort of eyeballing the difference between the mean in females, 29, and the mean in males, 14. Now, to me, those are a little bit different, but we'll get there in just a second. So go ahead and pull those over into your demo. Okay, so now that we've done that, let's go ahead and examine the relationship between actually two variables. So instead of just working with BDI for the rest of the lab, let's add in another variable here. And I wanted to just take a quick moment and say that when we're doing these sort of the statistical analyses, it's always good to start with a research question of interest. And it's something that we're going to start introducing to your lab starting this time around. So the idea of having like a background information or a research question of interest to sort of start off your analysis, giving your analysis a reason is a really good place to start. So I have two sample research questions here. Is there a relationship between gender and depression? And is depression severity related to gender? Okay, so these are the two questions that we're going to work on solving. Okay, and the first step is always to make a skeleton table. Okay, so here's our table, and I'm just going to name it the relationship between gender and depression, because that's really what we're asking for here. Okay, and we're going to look at two different measurements. We want to look at the mean and the standard deviation, and we want to look at the median and the interquartile range for that BDI. But instead of just looking at it overall, which is what we've done sort of above here, we want to add in the second variable. So the second variable for us is going to be gender, and we're going to have two gender categories here. We have male category and female category. Okay, so if we follow along with the steps here, what we want to do is we want to describe the relationship numerically first. Okay, and again, this is review. So what we want to do here, we want to go here, we want to say analyze, descriptives, and we want to explore. Okay, so I'm going to go ahead and reset this, because what I want to do is I want to pull gender into the factor list, and then I want BDI, the continuous BDI, because we want a mean and a standard deviation and a mean and an interquartile range, which means we need to use the continuous form of the variable. I just want to look at the statistics right now. I want to numerically describe everything. So I go ahead and say okay. And here we can see with the descriptives, we have the descriptives are broken up. Okay, so we have the mean, the standard deviation, we have the median and the interquartile range just for females, and then we also have it just for males. Okay, so you can go ahead and take the statistics that we have here on this column, and we can add them here to our table. Okay, so give it a second and go back and forth, toggle back and forth, and look to see if there are any differences that you can see sort of eyeballing the difference between the mean in females, 29, and the mean in males, 14. Now, to me, those are a little bit different, but we'll get there in just a second. So go ahead and pull those over into your demo. Okay, so now what we have is our table all filled out. Please note that all of my sig figs are correct, and please just make sure that you're rounding correctly as well. But this is what we got from our output in SPSS. So we have the mean and the median over here. We have the mean and the median over here for the two different genders that we're looking at. We have male and then also female. But that's not enough, right? Because we're working on visualizing the relationship between BDI and gender. Okay, so the best way to do this is to go back into our chart builder. And I think the best thing to look at would be to use the bar chart. Okay, so let's go back here and we go up to graph and we go to chart builder again, which is our favorite little tool today. Let's go ahead and reset this, but we still want to use the bar. So go ahead and drop that in. But now we have two variables. We want to see gender here down below, and we want to see BDI in the counts right here. Okay, so this is mean, BDI, and then this is gender. So we have male and female. Go ahead and say okay, and then our graph will come out. So we have female on this side, male on this side, and we can see here visually there looks to be a difference. I mean, we saw a hint of that when we were looking at just the numbers, but now for me being a visual person, this makes a lot more sense. I can see that females look like they have a larger depression score as opposed to males. It's very easy for me to see that here. Okay, so if we go back to our steps over here, the next thing that we're going to do, step 5, is we're still going to be visualizing the relationship, but instead of doing the mean, we're going to do the median. And the way to do that is with a box plot. Okay, so what we want to do is we want to go back, back to our chart builder. And again, just press reset, everything goes away. We want to do a box plot. So pull the simple box plot up into sort of the chart preview area. And we still want to have gender down here on the x-axis. And we still want to have Beck's depression inventory, the continuous variable. So not the one that we created, but the continuous variable here in the y-axis. So go ahead and say OK. And here what we can see is the female here on the left-hand side and the male here on the right-hand side. All of these little scores up here correspond to what's known as an outlier. So these, and I think I have this pulled in here, yeah. So I have these circled here in our demo here, but these are the outliers, meaning that there are several, a handful of the male participants in our research study that do not fall within the interquartile range. So the box plot, and then these are called like the whiskers here. So these are actually above the whiskers. And so these are actually known as outliers, okay? And so statistically, that means that they fall beyond sort of the average, okay? So these males, I can't really count how many there are right there, but let's just call it 10. There are 10 males that are actually very depressed. Their scores are very high as compared to the average male in our population. So they fall outside of the whiskers of the box plot. So the other thing that I'd like to note here is if we just went into the explore command in SPSS and instead of just asking for the statistics, but we also asked for the plots. The box plot is a typical or an automatic graph that will pop up. So in the explore command, if you ask for both the plots and the statistics, the box plot should automatically generate. So one of the things that we're going to be working on also in our lab too is not just giving me the skeleton tables all filled in or the histograms, copied and pasted, but we also want to continue to work on our ability to synthesize the data. So now we have a bunch of data here. We have numerically described data, we have visually described data in 2 different capacities. So what I want you to do is I want you to practice actually writing your answer in English words to say whether or not the mean, standard deviation, median, interquartile range, whether that be visually or have that be numerically, what does that look like? Describe it to me in words and use the space that you have right here in your demo to practice doing just that. Okay, so for part 4, what we want to do is we want to basically do the exact same thing that we did above, but instead of using BDI as a continuous variable, we want to look at it as a categorical variable. And the reason that we're doing both of these 2 things in the demo is because I want you guys to be able to have the tools in your toolbox to explore the data regardless of what type of variable you're faced with, whether it's continuous or dichotomous or categorical. I want you guys to be able to describe the data both through descriptive statistics, but also through the visual aid of graphs, irregardless of what type of variable you're dealing with here. But again, what we're going to do is we're going to start with some sample research questions. So here the research questions are, is there a relationship between gender and depression categories? Okay, so really important there that we've added that category. So we're not asking the depression score or the BDI, the BDI score, so the overall, we're asking specifically about the category. So are the categories of depression related to gender? Is there a relationship there? Okay, so step 1 is always to make a skeleton table. So based on my questions, I can go ahead and I can make my own skeleton table. So that's what I've done here. So we have the categories here, and I'm going to give myself a hint that because we're going to be doing some frequencies, I'm going to be reporting the N and the percentage for male and then also for female. So we're going to look at these two categories side by side with male and female all the way through minimal, mild, moderate, and then also severe. So we're going to go ahead and look at SPSS to do this. Now, this is a new thing. We have not done this before. The crosstabs command is going to be one of your very best friends. And we're gonna use the crosstabs command quite a bit in this class, but this is the first time that we're actually using it. So let's do it together. So what we want to do is we want to go back here to our cosmetic surgery. We want to go to analyze. We're still in the descriptive statistics category, but here we want to go down to crosstabs. Okay, so we've never used it before, so there's nothing here to reset. But we want to pull gender into the columns. And we want to pull our BDI cat, or our categorical variables here. Now, in order to get both the N and the percentage, the automatic crosstabs will only give us the N. So we actually have to go into cells, and we have to tell it that we also want a percentage. Now, I can never remember whether I want the row percentage or the column percentage. So what I usually do in the first time around is I'll just ask for both, and I can figure out when I have both which one I actually want. But I know, because I've done this before, that because gender is I'm just going to say continue, because gender is in the columns, it's actually the percentage of gender that I'm looking for. So I know that when I go to cells, I want the column percentage. So we can go ahead and press OK. And here we get exactly what we're looking for. So it's not exactly our skeleton table, but all of the information is there. So we can go in and say that we have, 74 males that have a minimal count, and we have 29 females that have a minimal count, but they're also giving us the percentage. So what we can do is we can go through and actually copy what we have here in our output, and we can go back to our demo, and we can actually fill in what we have here. Now, because I don't like to toggle back and forth, you can see that I've copied and pasted, or I've screenshotted, I don't know. I don't know how to say that. I have a screenshot here of the crosstabs, and so it's a little bit easier for me to fill in the columns here in my skeleton table. But it is very important that I stress that I do not want to see any screenshots. I want to see your created skeleton tables with just the information that I want to see, or that you are going to tell me here. Okay, so take a minute and copy and paste the numbers right here into the different cells. And when you're done with that, take a moment and just, in the space provided here, go ahead and tell me, based on your research question of interest, which we had above, do you think that there is a difference between males and females when we're looking across different categories of depression? Again, use your English words to describe what it is you're seeing here. Okay, so one last thing that I wanted to add on to this demonstration, just because it sort of completes the package here of what you can do with your sort of visualizing data skills, is I wanted to show you how to do a simple scatter plot. So what we're going to do here is we're going to work with two variables, and they have to be continuous. So we can no longer use gender, because gender is dichotomous or categorical. So we're going to be using age, which is a continuous variable, and then also depression, the BDI depression, not the one that we created. So what we're going to do here is we're going to create a scatter plot, and we're going to do that in our chart builder here. So what I'm going to do is I'm going to go over here, go to our favorite command, our chart builder, and go down here to the scatter plot and just draw up, just draw up the simple one is fine here. And because these are continuous variables, it really doesn't matter which one is in the x-axis and which one is in the y-axis, but I'm just going to put age down here and BDI over here. I'm going to go ahead and press OK. Whoops. And then here we go. We can kind of see, there kind of might be a trend sort of going up this way, meaning like the older you get, the higher your BDI score is. If you double click on this, you should be able to add a line I'm just going to close this. This is depending on, the type of fit line that you want, but this is sort of beyond the realm. So you can just go ahead and close this. But you can see here that as I added the fit line here, we have this line coming through here, and it actually gives us an equation to tell us the slope of that line, sort of where it's starting. So the constant, and then also the slope of the line. So if we just close out of this, yeah, it's going to be right here. So we can, again, right click copy, right click paste this into our lab, or we can screenshot this and put a scatter plot into our lab. Okay, so what you can do here, we can just go back and we can see that I've kind of screenshotted it here. And so again, as we're looking at this, we see that there's a slight positive association. I wouldn't even call it an association, a relationship, meaning that as we get older, our BDI on average in this data set seems to be getting higher as well. So just take a moment, fill in this space, and just write a sentence describing what we're seeing in our graph here. And then that's it. That's the end of our demo today. So thanks for listening, guys. And as always, if we have any questions, please reach out. But we're also going to introduce Lab 2 today. So all of the skills that we've learned here in our Lab 2 demo are going to be applied in our Lab 2 assignment. So thanks so much, guys. Let me know if you have questions.